Thanks for tuning in at Brackies.
Hello everyone and welcome to video number 5 in the How to Make a 2D Platformer course. Today we're going to be taking a look at something really awesome, which is importing and setting up our 2D character sprite. So today we're going to be both importing the graphics and setting up the import settings. And we're also going to be rotating the arm to always point towards the mouse cursor, so later we can do some cool shooting mechanics. We are not going to be setting up the animations today, that's for a future video. Cool, so throughout this video we're going to be using the 2D assets pack, which is of course available at brackies.com. So if I just load up the 2D course here, which you can access from the projects or from the homepage, then there's a download button that says download 2D assets, and it's completely free. It just downloads a zip file, so it should be easy to open and it's ready to use basically. Cool, so let's get started with today's video. I've already opened up Unity. And there's nothing changed here, everything is like before. So let's just start importing. So open up the 2D assets pack, open up the 2D platformer folder, and in here we have 2 new files. And these this cool astronaut is made by a guy called Arimet, and I'm probably gonna pronounce his last name wrong, so it's on the screen. And also you should check out his Facebook page, which is in the description. He's a really cool artist, so check him out. Also, to all of you who are currently working on a character or would still like to submit something to the series, please go ahead and just send me over stuff, and I might include it in the 2D assets pack still. Even though I'm going to be using the astronaut player for this course, other people might choose another one, so it's always great to have more in here. So cool. So let's actually let me just explain. We have a Photoshop file here for those of you working in Photoshop. If there's something you want to edit here, it's split up into different layers and should be pretty easy to access. And then we have a PNG, which we are just going to be using. You can import the Photoshop directly into Unity and it will take care of everything. But for simplicity's sake, and in case you don't have Photoshop installed, we're just going to be using the PNG. So let's take this and then simply drag it into Unity and release it over the project pane. And now let's select it and change the sprite mode to multiple. And change the pixels to units to, let's try 15. And then change the filter mode to point. Hit apply. Now we can go into the sprite editor, and in here we can select the different sprites. We'll do what's called slicing up the sprite sheet into multiple sprites. I've set up the sprite sheet to make automatic slicing pretty easy to do. So let's head up in the left hand corner and click slice and select the type automatic, and now we are actually ready to slice this. So you can see it sets it up perfectly. By the way, if you see these green circles around the screen, I'm trying out a new piece of recording software and it likes to do that for some reason. So now we can have a look at how our sprites are set up. So now we can see that it's actually set up everything perfectly. And if we want to check this, we can go up here in the right hand corner and change from RGB mode to alpha mode. So now we are just seeing the alpha channel and we can see that everything is actually selected just fine. So let's hit back into RGB mode and let's just select the arm here, and let's first off rename this to arm, and let's change the pivot to left. This way we can simply rotate around this pivot whenever we want the arm to rotate. Awesome. You could go ahead and name each of these sprites. I'm just going to go ahead and rename the astronaut idle and the astronaut jump. And then I'm going to rename the weapons. This up here is a full walk cycle, which we're going to be using when the character needs to walk around. So let's select the gun here. Let's select, let's call this machine gun. And let's call this one for pistol. I just quickly added that just so we had a smaller weapon to work with. Awesome. Now let's hit apply and let's close this window. And we are actually ready to start importing this into our scene. So let's open this up. Simply click the arrow here to opening up the individual sprites. And we can select each one of them. And what we want right now is we want to find the idle one. Here the astronaut. Whoops, I spelled that incorrectly. Let's head back into the sprite editor. Astronaut idle, like so. Cool. So select the astronaut idle and let's drag this into the scene. So simply click and drag and release. And this looks pretty nice in scale. It might be just a bit too large. I want the player to be pretty small, and then I want to fill up the space with plenty of explosions. So let's actually go under the import settings here and change this to, let's try 18 and hit apply. And this is much nicer. It's just a bit smaller than the player from before, which is fine for me. Cool. So now that we have this guy here, let's go ahead and drag him under the player. So first select the player and disable the sprite renderer so we can get rid of the robot. And let's have the graphics be a separate object, just a child of the player. This way we have more control over the positioning of the graphics and we can flip them when we change direction individually, so we don't have to constantly follow the player. So let's just drag the astronaut idle under the player object and let's just reset the position. And you can do this by right clicking on the transform and hitting reset position. So that will just zero out the position. And now let's simply drag him down a bit on the y-axis here. And again, if you are dragging something, click to drag and then hold down shift to constrain it to one axis. And that actually doesn't look too bad. Let's try and hit play. Just see how this functions. And it already looks pretty awesome. Cool. So what we want to do now is we want to add in our arm. And to do this, all we really need to do is to select our arm and then drag it into the inspector, or the hierarchy, I mean. And let's just drag this under our player object also. And let's just reset the position here, like so. Cool. Now we can take our arm and we can try and position it in the center of our player so that when we rotate it, it can rotate the whole way around without being weirdly placed. This looks pretty nice. And now let's select both the arm and the astronaut idle and let's change the sorting layer to player. And let's also, to make sure that the arm will always render on top of the player, let's change the ordering layer to 1. Actually, let's change it to 2 because later when we add weapons, we might want them to be below the arm but above the player. So let's change this to 2. That just makes sure that even though they're in the same sorting layer, it will still be on top. Cool. So what we can do now is we can place a script on the arm here that will rotate it towards the mouse cursor. But what we also want to do is fiddle around with how the arm is rotated when we equip weapons and such. That's something we're going to look at later, because right now you can see that the arm is automatically scaled with the character. That's not really something we want, so actually let's just go ahead and change that first. That will make debugging easier later. So let's go ahead and make sure that the arm is independent of the rest of the graphics, because right now it scales with them and that's not something we want. We want it to simply point towards the mouse cursor. So in order to do this, all we need to do is we want to select the player and let's find the platformer character 2D script. So let's double click this. And this was the script that we imported in the very first tutorial. Also, I might want to mention this. You can see right now that I have a theme on Mono Develop, which I just think is a bit more relaxing on the eye. If you want the same cool theme instead of the black text on white background, you can simply go under, I think it's, where are the options? It's Tools, Options, and then you can go down under text editor, then syntax highlighting, and change to Oblivion. You will have to click OK before it updates. So simply change it from default to Oblivion, and you can get the same color scheme. Cool. So first thing we want to do is we want to establish a connection to our graphics, because instead of changing the whole player, we simply want to change the graphics down here. So let's rename this to graphics. And let's simply store these graphics in a variable and then simply change the scale of those instead of the scale of the whole player. Because right now when we move all the way down to the button, we can see that we have a function called flip. And what this function does is it will flip the character to always face the direction it's walking in. And it basically does this by creating a vector 3 with the transform.local scale. And it then modifies the x value of that vector 3, simply flips it by multiplying with -1, and then it feeds it back in. But instead of transform.local scale, we want the child, here being the graphics.local scale. So in order to do this, let's make a new variable. And we're going to do a public. Actually, let's just make this private because we're not going to be assigning it ourselves. We're going to be assigning it in the awake function. So let's just do transform. And let's call this player graphics, and then a semicolon. So this will be a reference to the graphics so we can change direction. Then in the awake function, where we are setting up the references, we want to do player graphics equals transform dot find child. So the transform class has a pretty cool function that will allow us to find the child of an object, and this is better than doing GameObject.find because it doesn't have nearly as many game objects to look through. So we will find the child and we search by name. So let's open up some parentheses here, and inside of these two signs we will type graphics. Simply type in the name there, and we should actually be good to go. So now let's move. What we can also do actually is we can say that if our player graphics is equal to null, meaning that if it couldn't find, if it couldn't find the graphics object, we are gonna give it a warning here. So we are gonna do debug.log error. Let's do debug.log error, and let's say let's freak out. There is no graphics objects as a child of the player. This way, later when we get some bugs and try to change things around, we have clever error messages telling us what's going wrong. Cool, so now let's move all the way to the button. Instead of doing transform.local scale, we're going to do player graphics.local scale, and the same down here, so player graphics.local scale. Now let's save this out, and when we head back into Unity here and hit play, you can see that it's only our graphics that will change direction. The arm will just point the same way. Now let's make the arm point towards the mouse cursor. And in order to do this, we're going to have to do a few calculations. So let me just show you the basics of those here. So right now you can see, I'll just bring over the layers panel here also so I can enable and disable some layers. Cool. So as you can see here, we have a X and a Y axis. And this right here is the Oregon, so that's 0, 0. And we have a player who's standing at 1, 1. And then we have the mouse cursor, which is currently at 3, 3. So what we need to do is, first off, we need to subtract the position of the player from the position of the mouse cursor. So 3, 3 minus 1, 1 equals 2, 2. So that gets us the point right here. Then what we need to do is we need to use a function called atan2 that will go ahead and find a line that goes from 0, 0 up to the point 2, 2. And then it will return the angle between the x-axis and that line. And that's the angle that we want to add to our arm. So if that makes any sense, then great. If not, then I'm going to show you how to code it right now, and you can just skip over it, and it might make more sense when you see it in code. So let's try this out. Cool. So let's just move this over, and let's open up the mono develop. Oh no, we need to add a script. So let's select the arm. Let's hit add component, new script, and let's call this sorry, let's call this arm rotation. So create an add, and let's double click this to open it up in mono develop. So here we go, it's opened it up. And what we want to do is actually pretty simple. Unity has a built-in function for this called transform.lookadd, but this will allow us to will give us more control. The method we're going to be using now will give us more control than transform.lookadd, and also it will allow us to constrain the movement to just one single axis, which is the z-axis. That's what we're going to be rotating around. Cool. So in order to actually do let's just remove the start function, and then inside the function update, we're going to be writing some different stuff. Let's start out by writing vector3, and let's call this difference equals camera.main.screen to world point, and we're going to feed it our mouse position, so inPoint.mouse position. Let me just full screen this. Input.mouse position. And then we're going to subtract it with transform.position. So this is the first part of everything. We are simply making a vector3 called difference. And this is just going to be the difference between the position of our mouse in 3D space and the position of our character. Then what we're doing after is we are normalizing this. So we are taking the difference and we're doing .normalize. This is something you can do to 3D vectors in Unity. And what this does is, it sounds really complicated, but it's really not. What we're doing is we are clamping all these values to be all equal to 1. So when we take the sum of the vector, meaning that we say x plus y plus z, we will that will be equal to 1. So normalizing means that we still remain we still keep the same proportions between the different numbers, but we are just making all of them smaller so that when they are added together, they will equal 1. So this will still give us the correct point, and it will allow us to give us the right direction, but it's just doing smaller numbers. So here we are normalizing the vector. This meaning that the sum of the vector will be will be equal to 1. And that's basically it. So the importance of this I'm not going to go into here. And above this we are simply subtracting the position of the player from the mouse position. Cool. Then next up we are going to, let me just move this up to a line above. Let's just go like this, so we can see everything. Cool. Then in the next line, we are going to make a new float. And let's call this rotation. Let's just do rot z for rotation on the z-axis. And we're going to equal this to math.attan2. And then we're going to input the difference .y and the difference .x, and we are going to multiply it by math.rad2degree. So what we're doing here is we are finding that here, let me just get this over here. We're finding this angle. So we are making the vector between at this point. So we are finding the vector that goes from 0, 0 and then up to 2, 2. And then we are finding the angle between the x-axis and that vector. And then we are converting that angle from radians over to degrees, because they're much easier to deal with. So that's all we are doing. Here we are making a variable to store it in. Here we are finding the angle. And here we are converting it to degrees. Cool. So let's just comment this out. We are simply find the angle in degrees. As simple as that. And then at last we are simply going to apply this rotation. So we're going to do transform.rotation equals quaternion dot Euler, and that means that we will pass it degrees and not radians. And then we are going to do 0f, 0f, rotation set. And here we might need to add on 90. Let's just do plus 90 and see if this works. If it's rotated weirdly, maybe pointing in the opposite direction, we need to do negative 90. This is where you can correct that if you have some offset. Cool. So let's save this out and let's hit back into Unity. Actually, let's just store the offset in a variable. That's just good practice. So let's open it up here. Let's make a variable and call this public float. Let's just do an integer. That should be plenty. So public int rotation offset. And we're going to default this to 90. And then here, instead of 90, we're going to do rotation offset. Awesome. So now when we head back into Unity, we should see a variable here, and we do. And when we hit play, you can see that the arm actually follows the cursor, but we have the wrong side pointing towards it. So that's why we have the rotation offset. Let's try and just zero this out. And then it's actually working. Cool. So this, if you're using the arm I am, then just set that value to 0. But if you're using some other asset, it might be really useful. Cool. So now we actually have an arm that will point towards the mouse cursor. So that's really great. We've come a long way already. Let me just check the time here. So yeah, we've been going for a long time. I think we're just going to conclude with this. And then in the next video, we can take a look at stuff like animations, adding some weapons. There's plenty of stuff to do. You can see there's also already some weapons inside of the Sprite Atlas. So they're ready to being applied. So that's going to be really awesome. So thanks for watching, and I'll see you in the next video.